All right, in this video, we are going to talk about conditional probability. So, conditional probability, you have two events, and one event you're going to assume occurs or has already occurred. And then you're going to calculate the probability of a second event. So that assumption, right, that one of the events has already occurred, gives you a little bit more information about the events, right, that have happened or will happen, however you want to think about it. Okay, and so in this definition here of conditional probability, or at least the notation, we are going to assume that the event A occurs or has occurred. Okay, so they're giving you that information. So they're telling you, hey, this certain event has happened, right? And now, given that you know that information, what is the probability that some other event occurs? And that some other event, the event that we're calculating the probability of, is the event B. Okay, in how we have it in on this slide here. Okay. All right, and that's called conditional probability. You're calculating the probability of an event given that some other event has already occurred. All right, and the symbol that we're going to use for conditional probability is this vertical line that separates those two events. So this symbol down here would be the probability of B given A, is how that's read, right? And in this notation, we're assuming that the one on the right of the vertical line, the event on the right, has already occurred, or you know that it will occur, and then the event of that you're calculating the probability of will be over on the left of this vertical bar right here. So that's the probability of B given A, or conditional probability. Okay. All right, so now let's look at an example of how this would go. All right, so this is problem 4.134 from our book. It says a balanced dime is tossed twice. The four possible equally likely outcomes are heads heads, heads tails, tails heads, and tails tails. All right? And so we have a very small sample space here. There are only four elements in this sample space. Okay? And so because the sample space is so small, then we can list out the elements of our events. And anytime you're able to do that, it makes it very, very simple to calculate probabilities. So I'm going to go ahead and write all of these out. Now, if your sample space is large at all, right, then you're not going to be able to do it this way, right? If your sample space is big, then your events are probably going to be pretty big. And so writing out all like I'm going to do here is really not feasible. Okay, it would just take too long, be too complicated. Sometimes you don't have enough information to do that either. So in this first example, I'm going to write everything else, write all of the events out, because I just think it makes it clearer that way. You can see what's going on a little bit easier. But just keep in mind, in other problems, you're probably not going to be able to do that. Okay. All right, so they tell us that A is the event that the first toss is ahead, right? So we can look through our sample space and see we're looking for all of the outcomes where we have an H first, right? So that would be HH and HT. Okay, so that's the event A, and we can write that out. All right, event B is the event that the second toss is ahead, right? So looking through our sample space, we can see here the second toss is ahead, so HH is in there. Nope, there is tails heads, right, would be another element of B. So we could write that out. And that's it. And then event C is the event that when you flip the dime twice, you get at least one head. So we're looking for all of these that have at least one H, right? And so that would be HH, that has at least one, heads tails has at least one, and tails heads has at least one as well. Okay, so there we've got our events listed out. That makes it really easy to calculate these probabilities. All right, first up, they want us to calculate the probability of event B. That is not a conditional probability, right? Because there's no vertical line right in there. So that is just something that we have done in previous videos. So what you would do is take the number of elements in your event B, which are 2, and put that over the number of outcomes in your sample space, which is 4. So that probability is 2 over 4, or 1/2. All right, part B is the probability of B given A. So this is the first conditional probability that we are going to calculate. And so how you would calculate this conditional probability is that now we are given that event A has occurred, right? Before the video started, right, I flipped 2 dimes in a row, and I'm telling you that I got either a heads and a heads or a heads and a tails when I did that. All right, so now really what that means is that now A becomes our sample space, okay? So now we consider A as the possible outcomes. Either this happened or this happened. So that means that the bottom number is no longer 4, right? But it would be the number of outcomes that are in the event A, this one that we're given that's occurred, the one on the right of the vertical bar here. Okay. All right, so now then the top number, right, the number that you would put on top would be the number of elements that are in B that are also in A. Okay, so I would just check. Hey, here's event B, heads, heads. Is that in A? Okay, it is, right? So there would be at least 1. And then checking this one, tails, heads, is that also in A? And it's not, right? So there's only one element of B that's in A. So that would mean I would put a 1 right on top. And so if you're given that A has occurred, right, if I'm telling you, hey, I either got a heads heads and a heads tails, right, and you say, hey, well, what's the probability that the second toss is a heads? Well, it had to be 1/2, right, because there's only 2 outcomes, and only one of those outcomes, right, was one where I got a tail on the second toss. Okay, so that's how you would calculate a conditional probability. All right, or one way to do it, let's say. All right, part C, they want to know what is the probability of B given that C has occurred. Okay. All right, so this is a conditional probability, right? We're given that C has occurred, right? So now C becomes our sample space, right? And that means that the bottom number on our probability is going to be a 3, right? The number of elements in our sample space. All right, and then the top number would be the number of elements of B, right, that are also in C. All right, so I would just check. If I get a heads and a heads, is that in C? It sure is, right? So that's 1. If I got a tail and a head, right, is that in C? And that is true as well. So there are 2 elements of B that are also in C, so that would be the number that we put on top. All right. So if I tell you, hey, I was flipping 2 dimes, I flipped a dime twice, and I got heads, 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 tails, or tails, heads. What is the probability that I got that the second toss is a heads? Well, that could happen 2 ways, right? I could get a head and a head or a tail and a head. So the probability would be 2 out of 3, 2/3 on that. Okay. All right, part D. They want to know what's the probability of C. That is not a conditional probability, right? So we would just use the entire sample space, right? So the bottom number would be 4. And C has 1, 2, 3 things in it. So the probability that C occurs, that I get at least 1 tosses ahead, is 3/4. Okay. All right, part E. They want to know what's the probability of C given A, right? So that is a conditional probability. So our sample space now is A, right? We assume that event A has happened, so either one of these 2 things, right, is what occurred. So the size of our sample space is now 2, right? And then what we would do is go to C, and we would count up the number of outcomes in C that are also in A, right? So heads, heads, is that in A? Sure is. Heads, tails, is that in A? Sure is. Tails, heads, is that in A? No, right? So there are two outcomes in C that are also in A. All right, so I get 2 over 2, which is 1, right? If an event has probability 1, right, then we know that it's guaranteed to happen. So if I told you, hey, I flipped 2 dimes and I got a heads, heads or heads, tails, and I ask you, what's the probability that event C happened? In other words, what is the probability that one of these happened? You would say it has to happen, right? It's guaranteed to happen, because if you either get heads, heads or heads, tails, right, then that's also, both of those are also in C, so it's guaranteed to happen. If you know that event A has happened, then it's certain, right, that C has happened as well. All right, in part F, they want to know another conditional probability. That's the probability of C given not B. All right, not B, we don't have that listed out. So what we can do is just go up here and calculate out not B. All right. Remember, not B would be the set of all elements of our sample space, right? The whole sample space that are not in the event B, right? So I would just look. HH, is that in B? It is. HT, right? That is not in B, so that would be in the event not B. TH, is that in B? It is. TT, is that in B? It is not, right? So that means that TT is in the event not B. All right. So there's not B listed out, and that's going to help us, right, to calculate this probability that we want down there, right? This is a conditional probability, and not B is our sample space, right? So we know there are 2 elements in our sample space, right? And then the top number would be the number of elements that are in C that are also in not B. So heads, heads, is that in here? Nope. Heads, tails, is that in here? Yes, it is. So there's 1. Is tails, heads, is that in not B? No, it's not, right? So there is exactly 1 element of C that's in not B, right? So the probability that event C would occur given that not B does occur would be 1/2. Okay. All right. So like I said, in this case we had a very tiny sample space, so it was really easy to list out our events and calculate probabilities that way. Like I said, most of the time it's not going to be that way. Most of the time we'll have to just count the number of things in our sample space, okay? And so I just don't want you to feel like you have to list these out, because most of the time you can't do that. It's just easier to do it when you can list it out, and so that's the example that I thought we should do first. All right, we're going to do more examples, and what I'm going to do is just separate those examples out into their own videos.